We are going to cover notes today on solving absolute value equations. So step one, we only have to do if necessary, and it's isolate the absolute value expression. What that means is we want to get our absolute value bars alone. So if there's something in front of them or something after them, we want to get rid of it. We want to move it to the other side. Step two, we're going to drop the absolute value bars. And it's really important that we're writing two equations. So one equation is going to be set equal to the positive number, and one equation is going to be set equal to the negative number. So get rid of my bars, and I write two equations. One's positive, one's negative. So if I have two equations, we're going to have two answers. Step three, solve for the variable. And most likely that's going to be x. Now here's a little hint or a trick, because we've talked about absolute value cannot be negative because absolute value is the distance from 0 and distance cannot be negative. So if our absolute value expression only after being isolated is equal to a negative number, there is no solution. So we wouldn't have to do any work, we would just write no solution. So let's walk through some examples here. Number 1. The absolute value of 2x minus 1 equals 7. So step 1 says to isolate the absolute value expression. So that's our bars with the 2x minus 1. I don't have to isolate it because it already is isolated. If I look directly in front of it, there is nothing. And if I look directly after it, before my equals 7, there's nothing as well. So it's already by itself. So all we have to do is break this up into our two equations. Okay, so my first equation, what we would do is we just drop our absolute value bars. So I'm going to write 2x minus 1 equals 7. And my second equation, I'm going to do the same thing, get rid of the absolute value bars. So 2x minus 1 equals, and notice both equations have 2x minus 1 equals. That stays the same. Okay, but instead of having a positive 7 now, we want to write a negative 7. Okay, because if I put a negative 7 in here, it's going to turn into a positive 7. And if I put a positive 7 in here, it's going to still be a positive 7. Okay, so we can have this set equal to a negative 7 here for our second equation because I don't have any absolute value bars. Okay, so two equations. We're going to solve both of these the exact same way, but we're going to come up with two different answers. Okay, so if I'm going to keep my work organized, remember we can draw our lines down. And we want to get 2x all by itself, so I need to move my loose number. I want this alone. I need to move my negative 1, so it's the opposite. We would need to add 1 to both sides. So 2x equals 7 plus 1 gives us 8. Then we want to get our x all alone. So currently, there's a 2 out in front of it, and they're being multiplied. The opposite, let's divide by 2. Divide by 2. 8 divided by 2 is 4, so there's our first answer. And now I need to solve the equation again, and I'm going to get a different answer. But we do follow the exact same steps when we solve. So I want to get rid of or cancel out this loose number of -1 and move it to the other side. So the opposite would be to add 1 to both sides. 2x equals -7 plus 1. Gives us -6. And again, we want this x to be alone here. Currently, it's being multiplied by 2. So the opposite is to divide by 2. X equals -6 divided by 2 is -3. Okay, we got 2 totally different answers, but we solve these equations the same way. Question 2. The absolute value of x minus 3 equals -5. So this is saying what two x values are -5 units away from 3? Or what could I plug in right here that's going to give me a -5 units away? Well, that doesn't make sense, right? I can't walk -5 steps. We can't run -5 miles. We can't drive -5 miles. Whatever the case may be, we can't be set equal to a negative number, so this is no solution. We don't even have to do the work. No solution. All right, next. Question 3. We're going to start with a 3 times the absolute value of x plus 2 equals 21. So we are going to isolate the absolute value expression first here, which means I need to get the bars in x plus 2 alone first. Currently, there's a 3 directly out in front. 3 and the absolute value are smushed together. They're really close, so they're being multiplied. So the opposite is divide by 3, and these cancel. If I divide by 3 on the left, I have to do it on the right-hand side of my equal sign. And we're left with x plus 2 equals 21 divided by 3 gives us 7. So step 1 was to isolate the absolute value expression. We did that. So now we move on to step 2 of our note sheet, which says drop the absolute value bars, and we're going to write 2 equations. So what that means is I am going to start with this equation here and break it down into 2. So my first one and my second one. Don't go back up and make this a -21. So this is kind of gone. We don't use this question or this equation. It's null and void. We're going to move forward with this x plus 2 equals 7. So drop the bars. X plus 2 equals 7. Second one, drop your bars. Keep your x plus 2 equals, but this time we want it to be a -7. Okay. If you want to stay organized, go ahead and draw your line down through your equal sign and try to solve for x. Get x all alone. It says plus 2, so the opposite here would be subtract 2 from both sides. X equals 5 is my first answer. Again, on this equation, we subtract 2, and we get x equals -9. So make sure that you're writing both equations, that you're showing your work, and notice we get two different answers here. I get a positive 5 and a negative 9. Don't skip steps. Okay, write out all the work. Question 4. We're going to write the absolute value of x minus 3 minus 6 equals negative 2. Now you might be thinking, oh, it's set up equal to a negative number, so there's no solution. But hang on, we have to do some isolating and some work first. We need to get this x minus 3 alone first before we can look at if there's a solution or not and how do we write our two equations. So what we need to do here is get rid of this negative or subtract 6 that's after. So what's the opposite? How do we cancel it out? We need to add 6. Add 6. So we're left with the absolute value of x plus 3 equals negative 2 plus 6 is 4. This is a positive 4. So now we can set up our two equations. Okay, so this is gone. Don't go back up and try to use this. We're going to move forward with the absolute value of x plus 3 equals 4. So my first equation stays the same. I just drop my absolute value bars. My second equation, I still have x plus 3 equals. Instead of a positive 4, now we need a negative 4. And we're going to solve both of these equations the same way, which means subtract 3. X equals 4 minus 3. We get 1. Subtract 3. X equals negative 4 plus 3, or negative 4 minus 3, excuse me, we get negative 7. So every time we set up two equations, we're going to get two answers. Now we're going to flip or switch directions here, and we're going to move to some questions in the book. So find your book, and you're going to open to page 51 with me. And we're going to scroll down or find them where we see 11C and 11D in our book. Both of these absolute value expressions are already isolated. There's nothing directly in front of my absolute value bars or behind my absolute value bars. So what that means is we can skip step 1. So let's set up our two equations. X plus 2 equals 7. X plus 2 equals negative 7. And I want you to pause the video and go ahead and solve those. Subtract 2 from both sides. X equals 5 is our first answer. Subtract 2. X equals negative 9. Question D. 2x minus 1 is already alone. So let's set up our two equations. Equals 5. 2x minus 1 equals negative 5. Again, go ahead and pause the video, and I want you to try to solve these. Add 1 to both sides. So 2x equals 6. Divide by 2. X equals 3 is our first answer. And again, we're going to solve the second equation the exact same way. So let's add 1. Add 1. 2x equals negative 4. 2 and x are being multiplied, so the opposite. Divide both sides by 2. X equals -2. A few more questions, so go ahead and turn your page over to page 52, and I want you to work through A, B, C, and D. All of these are already isolated. So set up your 2 equations, and I want you to solve. You can do it. For letter A, we're going to add 5 to both sides. X equals 6. Add 5. X equals 4. Letter B, this time we subtract 5. X equals -3. Subtract 5. X equals -7. Those were both one step. So questions C and D are 2 steps. So we want to get 2x alone first, so we're going to subtract 3. Subtract 3. 2x equals 8. Divide both sides by 2. X equals 4. Same thing, subtract 3 on both sides. 2x equals -14. Divide both sides by 2, and x equals -7. For question D, let's draw our lines down again to keep our work organized. We want to isolate 3x, get it by itself, so I need to move the -4. So add 4 to both sides. 3x equals 12. Divide both sides by 3. We get x equals 4. Again, I need to solve the exact same way, so I need to move this -4, so I'm going to add it to both sides. 3x equals -4. Divide both sides by 3. And this time we get a fraction. X equals -4 thirds. So just a reminder, step 1, we need to isolate if necessary, which we didn't have to do for most of these questions. But then step 2 is we're going to set up 2 equations. One's positive, one's negative. Solve them both, and we get 2 totally different answers. Okay? And what stays the same is whatever is inside of our absolute value bars. 3x minus 4, 3x minus 4. Over here, 2x plus 3, 2x plus 3. That stays the same in both equations.